Okay. Oh, oops. Okay. Yeah. Well, maybe I could have waited another minute or two, but that's okay. Hi, everyone. This is the first community call of the new year. So happy New Year. Um, I think in the last call, we kind of talked about how 2023 was a huge year for Tempo. I think 2024 will be also huge. We have definitely a lot of stuff in the works. Yeah. Mario, this is the community doc. Great. Thanks for sharing that link. Yep. So that link is to the community doc that has our agenda that we'll be walking through and the kind of like the Q&A that we mentioned before. So yeah, you can open that up to follow along. It should be public. Hi, everyone. Okay, great. Yeah. So after the holidays, we kind of have a light agenda. There's not a lot of changes from last community call, but there is some cool stuff that we can go through. And I think we'll spend the rest of it, you know, if you have any questions or Q&A, like we'll have plenty of time for that at the end. Okay, cool. There were two really cool, really good improvements that were merged recently. So the first one is multi-tenant query support, or multi-tenant, yeah. So this is something that was kind of enterprise only, and it's making its way to open source. And what that lets you do is pass multiple tenants in the Xscope org ID header, and Tempo will query all of them and kind of combine the results and return it back to you. So if you're looking at a trace across multiple tenants, it'll look like one trace. It'll be reconnected and built back just like you would expect. We have support for searching, TraceQL, all that kind of stuff. So that's really cool. That's that first link in there. Yeah, go ahead, Mario.
Yeah, I think it was worth pointing out that streaming, we had some issues with supporting streaming with multi-tenancy, but we're working on it, and I think will be available in the coming days, weeks. Yeah, so if you see it doesn't work, release because you have a streaming enabled.
Yeah, that's a good point. Yeah, so the first PR was all the non-streaming versions of search. Yeah. And then we'll come back and patch that up. Cool. Okay, yeah, the next one was a really big PR. It's for the ingesters when they receive data. Previously, if there was an error on one of the traces in that batch, like it was too big, or the rate limit was met, the entire batch would be rejected. So it was kind of all or nothing. This change, Tempo will save what it can out of that batch and only reject the traces that had the error. So that was a great PR. Thanks, Jenny, for working on that. I think that was a lot of work there. So that one's really cool. So what you should expect is that you'll just have a lot more reliability, right? So you'll have fewer broken traces that shouldn't have been broken because it's a different trace that was too large. So a large trace in a batch could disrupt a lot of smaller traces that, if for no explanation, it would be very hard to troubleshoot that. So you see fewer broken traces. What you'd also see is just a higher ingest rate. So if you have a lot of rejected traces right now, Tempo will suddenly start doing more work because it will be saving more of that incoming data. Let's see, is there anything else we want to mention on that one? I can't remember if it's by default or if it requires a config option.
It's by default.
Cool.
The only thing to note is mainly that it will return a 200 now instead of errors.
Okay, yeah. So what that means is previously the agent or your pipeline, like the collector, would retry, but now it won't, right?
Wait, no, previously it was already a non-retriable error, so there shouldn't be anything different in terms of how things are handled. I mean, how things are being pushed. The only thing is it is returning a 200 instead of an error, so you'll see suddenly it looks like all of your pushes are going through. and we are ingesting more spans, but there are the span that were rejected, that would have been rejected because of trace too large or max live traces are still being rejected. The spans, but not everything after those spans are rejected.
Okay, cool. So might change observability and monitoring slightly. Yeah, cool. Cool. Yeah, so those are two really big improvements. They will be in the next release. The next thing is we have a really cool blog post coming up. Mario, maybe you want to talk about that one?
Yes. So it's a blog post about dedicated columns. This is a feature that we released in 2.3. That's right. Yeah, the latest version. Yeah, we're a bit late on the blog post. We intended to publish this shortly after the release, but it's gotten delayed. It will be published around, I think it's next Friday. And it has, it's a complete overview of the feature. It goes into an explanation of how it works and some interesting technical details, some benefits that we didn't anticipate at first, but we welcomed. They reduced memory and injustice. And yeah, and then finally some tips on how to configure, what tags to look for, and how you can build effective configs for this feature. So yeah, I'm looking forward to publish it.
Yeah, that's perfect. So vParquet 3 is default in the last release, 2.3. Dedicated columns are not automatic. You have to turn them on, and this blog post will have everything you need to know to which columns to choose and why. Yeah.
Yeah. Also, at the end of the blog post, we already hint on what our intended next steps are. Sorry, you mentioned they're not automatic. We hope to make them automatic at some point. So we're still exploring options. So hopefully no one will care about automatic columns dedicated columns because they're automatic and they improve tempo without you having to operate it, basically. But yeah, that's the feature.
Cool. Awesome. Yeah, there was one more item that I wanted to note. So we found a panic in 2.3, and what happens is if you have the new autocomplete, the TraceQL query aware autocomplete enabled, there are some queries that can cause a panic in the ingesters. It's kind of rough because it will actually crash all the ingesters at the same time, so it will disrupt like tempo. So there, I linked the PR. That's fixes incoming. I have a feeling we'll probably patch this as a 2.3.1. But yeah, we'll see.
Yeah, so to give a bit or more of detail on this bug, so this happens when you pass a filtering query in which one of the conditions, so the value for the condition is a special type, like duration or kind, which you can set client or server. So if you use that type for a column that has a known type, like say HTTP status code, we know that's an integer, that will create nil iterators and create a panic in the injustice. So it seems like a very low probability bug, but the results are pretty bad. Basically, yeah, it crashes all the injustice, which is terrible. So yeah, and yeah, definitely we will have to patch this. Guess the lesson learned is never have a switch statement without a default.
Okay, yeah, that makes sense. Or trust user input, I think, is also the lesson there too. Cool. Is there anything else we wanted to mention before we get into the Q&A? Looks like we got a lot of really good questions here. Before we get into that, I had a question of my own. Is anyone using dedicated columns with Bpark K3?
We are already using them, and we saw a significant performance improvement after enabling them. But exactly like what we were wondering, like, should we exactly like what specific labels we should resource attributes we should put in there? The ones that are like large and expensive and we don't query frequently, or the ones that we frequently access? I guess I don't remember which one we decided to do.
Yeah, good. You can answer that, Mario. Yeah, go ahead.
Yeah, so there isn't a single correct answer. You can go for both approaches. What we found is what works most reliably is choosing the more frequent and higher cardinality attributes. So basically the ones that occupy the most space. And that's because you're taking those attributes into their own dedicated column. So that frees up a lot of space for the rest of the attributes. So you get the benefit of this feature when you query attributes that you haven't put in dedicated columns. We find that works usually the best. So the bulk will be the attributes that occupy the most space, and then you can combine it with a couple or two of very specific attributes that you search by very, very frequently. And to find those attributes that occupy the most space, we have a subcommand or command in the tempo CLI, which will basically read blocks and output
Yeah, we have
how much.
The command
Okay.
to identify the high cardinality ones.
Yeah. So that's what we found to work the best. Yeah. It will also, this will be explained in the blog post.
Thank you.
Yeah, it's kind of a counterintuitive approach. Even the attributes you don't use, you get a benefit by moving them out because they make the rest of them faster. Yeah,
that's what
it's
that
really
was
neat.
Our dilemma. Like, should we put in the ones we query frequently and are maybe low cardinality, or some of the we have some that are extremely high cardinality, but we think they're not used that often.
Yep. So looking forward to the blog post. That'll be great. That'll all be in there.
Yep. Thank you.
Cool. Alrighty. Yeah. So for everyone else in the community doc, we just have we're gonna use the rest of this meeting here for just general Q&A, since we kind of had a light agenda and there's some questions in here. So yeah, feel free to paste them in here or things like that, and we'll get to them. So, or if you're not interested in this, feel free to drop. So let's see. The first one, how to diagnose or investigate issues when seeing a large number of tempo query front-end retries count. Zach, I see you typing in here. Do you want to take this one?
Yes, the context canceled, which is difficult to find out. What I want to see is the context around this error message, if there's anything else that would indicate cancellation. It's possible that the timeouts are too short, but I would expect to see a duration message for the reason for the cancellation.
Okay, I'll see if I can research more on that.
There is, this is an area where we definitely want to improve because all of these context canceled chain together. You can see that might indicate some kind of smell. But yeah,
So,
sort of what I want to see is if there's back-end errors or timeouts or something like that, some sort of upstream issue.
Some of these log messages are red herrings. So the queries establish a long-lived connection to the query front end for a job queue. Sometimes that connection gets disrupted or it times out, and that can be, I think, what's printed here too. So if this doesn't seem to be in response to read requests, it could just be that background kind of noise. But just based on looking at the logs pasted here. Yeah.
Yeah, I don't know if it's so much. I mean, I know that when we increase the concurrent shards or query shards, those kind of things, that this escalates, right? Or max concurrent queryers. You know, if we have a large number set there in the configuration, this gets really bad. So there's definitely
Okay.
happening in the back end maybe, or somewhere along the path that's causing this. I don't know.
What version are you running? I know there was a change that I think Adrian put up to check the error message a little bit more exactly, because we were using, I think it was like testing for equality, but we want errors.is, and I think that was a change that went in not too long ago. But basically, like a lot of the query jobs will get canceled if you get results. So if you're not getting results and you're getting errors back when you query, then that's kind of that's a different indication.
Yeah, I was looking. We're on the 2.3. I'm trying to say 2.3.1 is what we're using.
I think that should have the fix. Yeah. This could be a good Slack conversation too. It might take a little bit of time to investigate.
Yeah, that'd be great. Maybe I'll just follow up some more there once I dive into this a little more too.
Yeah, I think a long-lived connection is established multiple times from the same query pod, depending on that concurrency level you mentioned. What was the, you know what your setting is, maybe? Like, I think we use 50. Concurrent requests is 50. And I think that will mean it'll establish 50 connections to the front end per pod.
You're talking about max concurrent? Which
one? It might be max underscore. Yeah, I don't know.
Yeah, max underscore concurrent queryers. Yeah, I think the default's like around 40 or something, or 50, right? And then we noticed that we tried to grow this to get better performance. We had it set at 500 at one point. That just created all kinds of issues. We decreased it to 10, and that seemed to actually improve things for us. And so I don't know if that's a symptom of something.
So there is one more variable. It's called like batch size and max concurrent. So I would say like play around with that.
Again, batch size?
Yeah, batch size in the front end.
Batch size, okay.
Yeah. So basically batch size is how many jobs. So each query will be split into multiple jobs. And then batch size decides how many jobs to push.
Yeah, and I have with that too, and it's at 25 right now. We had to minimize that as well to help configure because of the errors we were getting.
Yeah, and then max concurrent is, as Marty said, like number of active gRPC connection from one query to front end. Yeah, and other than that, I would say like if you are seeing a lot of retries and all, maybe try bumping the timeout. It's probably not a good idea to make it too high, but say tweak it around and see if it helps.
And you're talking about the gRPC timeout? Or what timeout are you talking about?
I don't really have the flag on top of my head, but the timeout between like the query to query front end. So should be in the front end config or query configs. Like I'll try to find it out and post it in the Slack.
Thank you. That'd be great.
Yeah, I mean, it sounds like this is just general like query tuning. So I think we might have to take that offline and dig into it a little more. Maybe get some more metrics from your side and things like that. That would be helpful. We can follow that up in the Slack. Cool.
Sounds good then.
Okay, I think the next one, let's see, testing gRPC connection limits. Yeah, maybe you could explain this question a little bit more. Do you have a copy of this RPC error that you're seeing?
I think it was more of a general question of like a theory that maybe we were hitting some kind of limitations as far as the network is concerned, that maybe there was something there. And so it was more of trying to find out what those are. But I know that isn't the gRPC list and connect limit set to 100 in the code or something like that? But you can increase that, correct?
That's a good question. I don't think I've had to configure gRPC connection limits.
I think
I'm looking at our configs right now.
yeah, the default I'm seeing is that it's set to 0, so there's no connection limit. But if you are getting connection limited by gRPC, you will get an error. It's pretty reliable about submitting errors. So if you're not seeing errors, then I would say that's probably not what the issue is. I mean, it's possible you have other things going on in the network for sure. But
And the different RPC errors are separate from that, correct? As far as the context canceled, those kind of things, those would not be related to the gRPC connections or anything like that, or retries even.
it wouldn't be context canceled you'd be seeing for that. You would be getting a gRPC message like connection failed or some other kind of gRPC indication.
Okay, thanks.
How many queryers do you have?
It depends. We tested a lot of queryers and decreasing all the different things because we were seeing all these RPC errors, decreasing things and making them taller instead of making it wider, right? Seemed to get us greater performance. So we played with a lot of different variations of this. So, I mean, but we've stacked actually pretty heavy resources on the queryers to be able to handle a simpler connection and sharding and stuff. So
I found out the query timeout config. It's queryr, and then under search, you should see query underscore timeout.
Suraj, can you paste that in this talk?
thank you.
Yeah, will do. Thank you.
Yeah, I was just wondering about like if there's a kind of an upper limit just from query front end to queryers that maybe we haven't run into. I think most we've done is like 200 queryers, something around there. And the concurrency is like 50, I think that we mentioned, maybe 100. So if it was a lot more queryers than that, or to query front end, maybe it doesn't multiply up or scale. Like maybe there's an upper limit there, but wasn't sure if that was possible.
Yeah, that's not what we're.
Okay.
Yeah, but as far as the query timeouts, we did grow those huge just in case, kind of like what you're talking about. And so both trace ID and search query timeout is set at 300 seconds. So we were just, opening up wide to make sure that wasn't a problem, and that's still not fixing the issue.
So I was fighting timeouts a little bit recently. So are you using a proxy? And so I guess the 3 places that I would recommend checking the timeouts would be any proxy that you're using for Grafana, the Grafana data source timeout as well. And then, the tempo timeouts. So I think if the connection closes right now on the client side, you'll get the context canceled messages. But if you're getting results for your queries, that's a different, like if you're having success with your queries and you're seeing context canceled, I think what Marty was saying earlier about the red herring makes sense.
Okay, no, that's some good feedback. Thank you.
Cool. Yeah, we'll move on to the next question. I think there's definitely a lot of, we could look at this a lot. I mean, I'd be really interested to see metrics and stuff, but cool.
For sure.
Yeah. Caching control. So caching control is unclear. I agree. I think this is an area that I think is not used. Caching in Tempo in general, I think, is kind of an underutilized feature. I will say before we answer this is that a lot of it's being rewritten. I can't remember if that PR, I think that PR was changed. And so I think this question is about the older caching. Yeah, so this one about compaction level. So the idea is caching is you want to store the Bloom filters like for trace ID lookup. That's the primary use case for caching. We had some other changes in here. Yeah, I'm actually not sure. So if you can't store all the Bloom filters, you could cache a subset of the blocks. And this caching control was a way to determine what subset of blocks that would be, right? There's like the benefit of caching the most recent blocks is lower because they're going to be compacted and replaced quickly, right? So you've cached that and it's already been obsoleted by new versions of those blocks. Caching really old blocks is also not useful because maybe they don't get hit as much. So this was a way to kind of choose the subset in the middle based on the compaction level and the block age. But I will say that I would probably not invest too much time in this because we're going to be making a lot more changes in this caching. So just to be making way more use of cache, they actually cache the block contents themselves as needed. I think we're doing some results caching so that we don't even have to read the backend if you execute, the same trace lookup or same search and things like that. So that's kind of a non-answer, but I would say just wait maybe another release or two, if that sounds good to whoever's question this is. Yeah. Okay, cool. Yeah. Yeah, and I mean, it will be way better. Yeah, for sure. The new caching stuff that we're working on. Cool. Would it be possible to add the same log lines for queries present in Loki? Oh, okay. Yeah, absolutely. Okay, so I think Jiraj dropped, but yes, absolutely. I mean, if you would like some better instrumentation, log lines, span attributes for tempo tracing, things like that, PRs are welcome, especially if this is something like you know more. I think you would probably know more about this than us. So that sounds great, like these log lines.
I think we sort of already have this information, but maybe it's not well formatted and synthesized into a single log line. Because yeah, these are I was reading the blog post. These are log lines which will tell you this endpoint was called, it expected this many bytes, took this time, this is the throughput, and all these type of metrics. And yeah, I feel like we have those metrics, but maybe they're not very accessible. So yeah, definitely. Here's our work.
Okay, how to tune the query path. Okay, yeah. So I think for this question, we can kind of just talk about like high level goals of how to tune the query path. Siraj has mentioned some specifics here, but I think like we need to take a step back and just talk about in general, like what we're trying to achieve, because based on your traffic and cluster size, and machine size, things like that, there will always be, tweaks. The tuning for trace ID lookup and search are different. So I would start there. So I would see which one you want to focus on. For trace ID lookup, it's primarily about making sure you're caching for those bloom filters, making sure it's large enough to hit the bloom filter, to contain the bloom filter for all your blocks. So that will avoid backend reads as much as possible. Making sure compaction is effective so that the block list is kept smaller. Will keep trace ID lookup better. Yeah, for searching, it's all about scale. So it's all about going wide. That would be the main thing. So having enough queryers to execute the job at the scale that it needs to be. Just tuning the query, like I think that's a big part of it, right? Using span dot or resource dot instead of the unscoped dot. Those other ones will always be faster. Using intrinsics, there's like kind of like a fast path for TraceQL, so you can write your queries that way. So without even talking about config options, like those are the high level goals of how like we think about tuning the read path. I wish if we had specifics, I think we could dig in, but yeah, we can talk about the config options that Siraj has mentioned here.
Could you also talk about maybe query shards, concurrent shards, how that plays into it as far as the trace ID goes, and how to fine tune that or know where that needs to be set?
Sure, yeah. So for trace ID lookup, what Tempo does is it checks the Bloom filter for every block. The Bloom filter says yes or no, the trace is possibly in here. If the trace is in there, then it opens the block and returns that subset of the trace. It could be a partial trace, like if the trace is across multiple blocks. So the idea is that we need to check each block really quickly, right? But you have to check each block once, and then we want to do it really quickly. The shards is how many groups your block list is divided into. So if your block list is 1,000 blocks, right, and you have 10 shards, each individual pod, the query pod, will have to check 100 blocks, right? So you want to scale that up, but you don't need to scale it up infinitely. Like you don't, it's slower if you create too many jobs. So that's the sharding for trace ID. So you can do things like 256, 512, 1,000. Like I think those are reasonable values. I wouldn't get much higher than that. Make sure your block list, your compactors are effective and your block list is kept down. For example, a cluster that gets 1 million spans a second, I would expect to have 100,000 blocks or less, right? I've seen clusters, smaller ones that maybe receive 10, 20,000 spans a second that are, the compactors aren't being very effective, and they'll have 100,000 blocks, and that's a lot for a smaller cluster like that to go through.
So if, like, let's say the block list was running around 1,500, so where would the
1,500 blocks? Yeah. For 1,500 blocks should be no problem. A couple queryers should be able to do that. The Bloom filter checks should be fast. So you want to avoid reads from object storage for all of those Bloom filters. So reading those out of Memcache or Redis if you have it, that should make that a lot better. If you're using real object storage, I won't think performance would be a problem. But sometimes for on-prem, right, like the object storage you're using, if it's like a custom, like S3 compatible product, for example, it might have its own configuration needs and things like that, and different performance. So it kind of makes that hard to answer.
Yeah, we have noticed, because we're using Pure Storage, FlashBlade, and we did notice that we get greater performance on an AWS S3 opposed to that. So
yeah, it can be tough because like we can't, like that's not something we're experienced with, and we don't work with it. So it's hard for us to, like there's only so much we can help out there.
Is that an S3 API?
yes, yeah.
For on-prem, I have a hunch that you probably want to reduce concurrency.
That's what we've noticed. Actually, when we reduced the concurrency, we got greater performance, which seems counterintuitive, right? As far as what you're trying to do, increasing the sharding.
You might also raise the job size. There's a target job bytes for the search path that, yeah, I think if you raise that, then that should reduce the round trips. But yeah, it does operate differently than S3 because S3 you want to go as wide as possible. But I think for on-prem, I think that calculus changes a little bit.
That target bytes per job type thing is only applies to searches, right?
Correct.
Yeah. Thanks.
Yeah, let's talk about the couple of these settings. Max concurrent queries. So that's how many jobs the query will run at the same time. That's not how big the job is. Like you could have really big jobs and a lot of them. And then in that case, if this is too high, you could be overloading your query or pod. Queryers are generally mostly IO bound, I think, reading from storage for search. But, depending on the query and things like that, they can use a lot of memory or CPU. So this is mainly about how densely and hot you run those query pods. So I would get that as high as you can, but no higher. I think we mentioned like 50 or 100 is a reasonable value for that. That's what we've run in some of our larger clusters. I would be surprised to see much higher than that. Yeah. Search.query timeout. So that's the timeout for an individual job within a big search. So if you, let's say you're doing a trace-scale search over 24 hours or something, in the UI on the outside, you might have like a 60-second timeout. But internally, Tempo will create thousands of sub-jobs for that search. Individually, those have much shorter timeouts, only a couple of seconds. If they're too long, then by the time they fail and time out, then you have to execute it again. That makes the search really slow. It increases the tail latency, right? Because it's only as fast as the slowest job. So that query timeout is usually 10 seconds or less, usually just a couple, right? Sometimes it needs to be increased if just the jobs can't get any shorter, right? You just have big blocks or heavy queries. Max batch size, query frontend dot max batch size. So this is kind of something that was new, that was added in the past couple of releases. They used to send, query frontend used to send one job at a time. This can send over multiple. This is mainly useful for at big scale. So we actually found at large scale, we sent the queries really wide. We had a lot of queries. We're seeing how high can we scale. The bottleneck was actually the query front end sending the jobs over. We wanted to search a big range of data, a lot of data. It created hundreds of thousands of these jobs. That was the bottleneck, was actually sending them over. So this batch lets us send multiple over the same time. So just reducing packets and IO latency between the two pods. So you only need to really worry about that one, I think, if you're operating at that scale. That would be something. So I would look for, I think we have log lines or even Tempo's instrumentation for the query front end. It will tell you how many jobs it has. If that's like 100, 200, 300,000, then you would benefit from customizing that batch size. But if it's 10,000, 20, that won't be your bottleneck. Okay. Yeah, is there anything else you want to mention about the query path?
You've given me a lot to look at, so I'm good.
Yeah.
Thanks.
There
There's
is a
also-
lot. Yeah.
Oh yeah, I just dropped a link to the documentation about some notes that we've written up.
Okay, cool. Yeah.
Also, if you see something weird, like feel free to put it down in a GitHub issue, because like we are also trying to understand how these variables play with each other in the query front end.
Sounds good.
Keep moving on. And then, hey, I copied one question from the chat out to the doc. So about the compaction level, I do have some thoughts that I want to add on that one too. But first, when would you recommend using serverless? So if I take a step back, I'll say serverless, I think, didn't deliver the scale and performance that we hoped it would originally. So I would say usage of it is limited. It's where you have to go when you have high scale, big queries, big tenants, and it's just not feasible to run a Kubernetes cluster of queryers because they're sitting idle most of the time. Generally, I think you're going to see better performance by just scaling out your queries a little bit more and not investing the time in serverless for most clusters. The performance of the real pods is just better. The latency, the instrumentation, the debugging, like the log messages, the metrics from those pods, we lose a lot of that with serverless. So I would say if your cluster is like in the million span per second area, then maybe serverless is feasible.
So with smaller clusters, you wouldn't expect better performance necessarily with serverless.
No, not necessarily. So the latency of the individual jobs for serverless is longer. So it kind of makes things slow. Even if you're scaling out, they're not really getting any faster because that tail latency isn't coming in. So that's part of it. Yeah, I mean, maybe it works. I mean, if you're interested, I would say go for it. Yeah. But in our case, we generally don't see a huge benefit until we get into those like larger clusters. Like I said, around 1 million spans per second. Maybe it's 500,000 even.
Yeah, like our Tempo is nowhere near that size.
Yeah.
Yeah, maybe like just on the original question, I had to drop from the call for a bit. I can just mention, yeah, like, you know, in Mimir, I don't know how familiar are you with Mimir Lonky, but you have these nice log lines that you get for every single query, which is like how many bytes it touched, things like that, of all of these useful statistics, which are very nice to understand, okay, and including the query it ran, which you get for every query. So I would be just interested, because we do have that for Mimir and Lonky, and we're missing that for Tempo. I guess, as I said, I'll raise an issue and look at where would be a good place to stack those in.
We do have some. Maybe they're missing the data that you want, but I know I personally added a log message that had a lot of that data in there. So maybe
Is it then like debug? Because with Mimir and Loki, there's like, I think, a specific flag where you can enable it even without enabling the debug logs.
yeah, I can't remember, and that maybe that's the issue.
Where we don't use the debug logs because they're very tricky. But like, we're specifically interested in getting the logs with like all the queries that there were and like the other. Yeah, I'll look around for if it's potentially behind that debug, and then maybe that would be the option to like have a feature flag that enables that specific log message with an info level.
Mm-hmm. Cool. Okay, so about compaction. What are the desired levels to look for, like 50% of blocks in level 2? So I think I want to take a step back and just say compactor effectiveness is another area that it's dependent on traffic, it's depending on your cluster size. It's, you know, if compactors aren't working well, but your read path is tuned, it could be no problem. Like it kind of cancels each other out, right? So I wanted to mention this metric here, which is tempo compaction outstanding blocks. So this is a good metric, so you know, compactors know all the work they need to do, and they record this metric for it, even if they can't get to it. So if this is a good way to see how far behind they are. So you want to see this. It's really hard to say like what value is appropriate for your cluster, but because this is the number of blocks, you could compare that to your regular block size and figure out, oh, it's 90%. You know, if it's something high like that, you know, if your compactors were scaled out, you'd have a lot fewer blocks. You know, what you don't want to see is this number growing out of control, things like that. Yeah, Zach has mentioned the compaction window. So that's a good way to tune compactors, is the compaction window. As you grow in scale for a tenant, you kind of bring that compaction window down because it lets you divide the work among all the compactors better.
Yeah, and I was just mentioning the block size too. It'll help keep the block size down.
Yeah, so there are also block size limits. Like what you don't want to happen is something like a compactor spends an hour working on one block and then crashes or ooms, or the pod gets descheduled and all that work is lost. So by setting the block size limits, you can kind of make that work more reliable.
A lot of questions today. I love it.
Yeah, this is great.
I recognize some of these names from Slack, but yeah, feel free to always join our community Slack. We've got at least a couple people hanging out in there every week.
Okay, well, I think we got through them all. Did we miss any that were mentioned in the chat? Cool, okay. All right, well, I guess we'll wrap up. All right, thank you, everyone. These questions were great. Thanks for joining. Yeah, good to see you all. Okay, and we'll see you next time.
Bye, everybody.
All right, take care.
Bye, folks.
Thanks.